Students, let us solve this JEE Advanced 1978 question number 8. This question is related to electrostatic chapter, and this is a very old question, but we will solve this question. A rigid insulated wire frame in the form of a right-angled triangle ABC. There is a wire frame ABC, A, B, C, which is insulated and rigid. It means this wire frame will not move. Is set in a vertical plane as shown in the figure. The wire frame is in a vertical plane. It means that gravity is acting downward. Two beads of equal masses m each and carrying charges q1 and q2 are connected by a cord of length L. There are two charge particles, one is q1, second is q2. Both have same mass. The mass of q2 is m and the mass of q1 is m. Mass is given. Both beads are connected by a cord of length L. So length of this blue line is L. Can slide without friction on the wires. This bead can slide without friction on this wire frame. This bead is also can slide on this wire frame without friction. Considering the case when the beads are stationary, okay, we have to consider a special case when this bead 1 is at rest and this bead 2 is also at rest. We have to determine the following things. First is calculate the angle alpha. So we have to find out this angle alpha. Second, the tension in the cord, the tension in this cord. Third, the normal reaction on the beads. There is a normal reaction on this bead where this wire frame AB. We have to calculate that normal. AC wire frame also apply a normal to Q2. We have to calculate that normal. So in first part we have to calculate alpha tension N1 and N2. What is the second case? If the cord is now cut, okay, this wire is cut down. What are the values of the charges for which the beads continue to remain stationary? So in this part we have to cut this cord, but this charge Q1 and Q2 still remain stationary. For that we have to find out value of charges. Okay, so first we calculate this part and then we go to this part. This charge Q1 and this charge Q2 is stationary and the distance between them is L. So the electrostatic force F equal to K Q1 Q2 by L square. Now we have to make the free body diagram of both charges, this Q1 and this Q2. So let me denote this Q1 at this point. This AB line is this angle 30 degree. This is the normal to AB line and this blue line is represented by this line making angle alpha. Now for all the components it is easy for calculation if we break the components one along this plane and second perpendicular to this plane, it means in this direction. So first mg, the component of mg along the inclined plane have value mg sin theta. Theta is 30 degree, sin 30 degree 1 by 2. So this value is mg by 2. The component of mg perpendicular to the inclined plane is mg cos theta. Cos 30 degree root 3 by 2. So this value is root 3 mg by 2. Okay. The normal reaction will act in this direction. We don't know their value. So let me assume that N1. The electrostatic force, it is not given Q1 and Q2 have same nature or opposite nature. So I assume that both have same nature. So the force is repulsive in nature and acts along the cord. So this is the electrostatic force We assume that its value is F, so this is F. The tension force will act towards the cord. So the tension force will act in this direction. So this is the tension force. Now we represented all the forces on charge Q1. So the sum of all these forces must be 0. Okay. Similarly for Q2, this is the situation, this is the inclined plane, this line is perpendicular to the inclined plane, or this is the direction of cord. If this angle is alpha, this is 90 degrees, so this angle is 90 minus alpha, so this angle is 90 minus alpha. Let me break the component of mg. So component of mg along the inclined plane is mg sin theta. Theta is 60 degrees, so this component is root 3 mg by 2. This component is mg cos theta, cos 60 degree 1 by 2, so mg by 2. Normal reaction will act in this direction. N2, electrostatic force. So electrostatic force repulsive, so away. So electrostatic force is in this direction and its value is F. Same force F, F. Tension along the cord, and its value is T. So we draw the free body diagram of both Q1 and Q2. Sum of all these forces and sum of all these forces must be 0. So let me break the component and equate the opposite forces. This is T, this is and this is F, so it is easy that we write it T minus F and eliminate this part because it make our calculation easy. Similarly, this is F, this is T, both are opposite in direction, so I can write it as T minus F. And let me eliminate this part. Now, the component of this force along this line is T minus F cos 90 minus alpha. Cos 90 minus alpha means sin alpha. So this force is T minus F into sin alpha. One component is along this line. If this part is sin alpha, then this part is cos alpha. So T minus F into cos alpha. So we break the component of this part. Now I don't need this force because we already break into two components. These are the two components. Similarly, we can break here. One component is along this line. This is cos alpha part. T minus F into cos alpha. Again, second part is along this line. This is, if this is cos alpha part, then this is sin alpha part. T minus F into sin alpha. Okay, so we have to rub this part because we already break them into two components. Now this is our diagram. So for equilibrium, for a stationary condition, this force must be equal to this force must be equal to sum of these two forces. Similarly for Q2, this force is equal to this force and sum of these two forces equal to this force. So I got 4 equations. So to solve 4 equations, we need some patience. Let me rub this part because we have move ahead for solving equation. This part N1 equal to root 3 mg by 2 plus T minus F sin alpha. Okay, this part equal to this mg by 2 equal to T minus F cos alpha. Okay, now from here root 3 mg by 2 equal to T minus F sin alpha. N2 equal to this plus this. N2 equal to mg by 2 plus T minus F cos alpha. So these are the four equations. After solving these four equations, we can get four values. First, note that we don't know N1, we don't know T, we know the value of F. This is the F. We don't know the value of alpha, mg, T alpha, mg, T alpha, N1 and N2. So there are four unknowns and there are four equations. Let me solve these four equations. This is equation 1, equation 2, equation 3 and equation 4. Dividing equation 3 by equation 2. This part T minus F cancel, sin alpha by cos alpha, tan alpha. Tan alpha equal to root 3 mg by 2, mg by 2, mg by 2, mg by 2 cancel, sin alpha root 3. So this part is root 3 by 1. So alpha equal to 60 degree. So we got our first answer, alpha equal to 60 degree. So first part is calculated. Now if I know the value of alpha, we can calculate the tension. So from equation 2, mg by 2 equal to T minus F cos alpha. Alpha is 60 degree, cos 60 degree is 1 by 2. 1 by 2, 2 or 2 cancel. So tension T equal to mg plus F. What is the value of F? This is F. So tension T equal to mg plus K Q1 Q2 divided by L square. So we also calculated second part T. Third part N1 and N2. N2. Oh, T minus F cos alpha. T minus F cos alpha mg by 2. mg by 2. mg by 2 plus mg by 2. mg. So value of N2 is mg. Similarly, T minus F sin alpha, T minus F sin alpha. This part equal to root 3 mg by 2. Root 3 mg by 2, root 3 mg by 2. It means N1 equal to root 3 mg. So we calculated all the parts N1, N2, T alpha. N1 is root 3 mg, N2 is mg, tension is mg plus K Q1 Q2 by L square and alpha is 60 degree. So alpha, tension, N1, N2. Now this question said that find the value of charges so that after cutting the tension both the beads remain at rest. It means that when we cut the cord, this T becomes 0. Now for second part, this T becomes 0. It means mg plus K Q1 Q2 by L square. Sum of these two forces must be 0. That is Q1 Q2 equal to minus mg L square divided by K. This is the product of two charges. We cannot calculate the value of Q1 and Q2 individually. To calculate Q1 and Q2 individually, we need a certain equation which is different from their product. But our all equations contain only F, and F have Q1 and Q2. So we cannot calculate the individual value of Q1 and Q2, but we have find out the condition. The condition is that both the charges have opposite nature, because this is the minus sign. So when cord is cut out and beads are remain at rest, then Q1 and Q2 must have opposite sign and their product must be equal to mgl square by K. K is 9 into 10 to the power 9. So this is the complete solution of the problem.